Hello, this is Mr. Trewick with a quick guide on how to finish Lesson 2.4 Linear Programming. This was related to our last lesson, 2.3, Finding Maximum and Minimum Values, and so this video can also help you with that. The first situation is about an exercise program, and it has different constraints with walking from only 10 to 20 minutes and running from 30 to 45 minutes. And we're trying to maximize the value to burn the most calories. Well, the constraints that are put in form this graph, and we're looking for the section where all the graphs overlap, and that makes this pentagon shape right here. The vertices, or the corners of this shape, can tell us a maximum value, or a minimum value if that's what we're looking for. So what we first need to do is find, or write down, where those vertices are. And it doesn't matter which order you go in, but I'll go in alphabetical order. Point I is located at 10:45. Point J is located at 15:45. Point K is located at 20:40. Point L is located at 20:30. And point M is located at 10:30. Now, looking at our question down here, we're going to plug these points in to our objective function, 6x plus 15y, and we are looking for the maximum value. That means the largest answer that we can get. So let's take a look at our points and see if we can eliminate any of them just by looking at it. Looking at these first 2 points, 10:45 and 15:45, they have the same y value of 45. But since 15 is bigger than 10, we can eliminate the 10:45 because we know we'll get a larger value with 15:45. Looking at the bottom 2 points, 20:30 and 10:30, we see they share the same y value, so we know the lower x value cannot give us the maximum value. And then looking at the third and the fourth here, 20:40 must give you a higher answer than 20:30 since the 20s match, so we can eliminate 20:30 as well. So that gets us down to 2 points, and that means we have less that we have to plug in. So the first thing is to take 15 and 45 and plug it in for x and y, 6x plus 15y. So we're going to plug in 15 for x and 45 for y. And then you multiply those two out, add the two answers, and that gives you some value. For the second one, we'll plug in 20 for x and 40 for y. Multiply those out, add those two answers, and that will give you another value. Whichever one of those two is the higher number is your maximum value, and that goes down here for number 1. It'll just be one number. For numbers 2 and 3, it's asking for the x point, that would be how many minutes you should walk, and the y point, how many minutes you should run. Well, looking back up here, whichever one of those two combinations gave you the higher number, you're going to use that x number and that y number. If it's 20:40, it would be 20 for number 2 and 40 for number 3. If it's 15:45, you'll use 15 for problem 2 and 45 for problem number 3. Let's scroll down to our next section. This is where a man owns a painting company and is trying to minimize his cost. And the experienced crew gets paid $1,000 a week and the novice crew $750 a week. These 4 inequalities right here form constraints. Constraints limit what can be produced. Those are the 4 things that you should type into a Desmos graph. So over here is what that looks like. Now, because of the way the problem is written, 0, 0 makes no sense. So I added that a little bit after I posted to take out 0, 0, and don't worry about using that as one of your vertices. So we're left with those 3 points, 0, 4, 1, 3, and 2, 0. Just like in the last problem, you're going to take those 3 points. Well, first of all, you're going to put those in as your vertices and type those in. You're going to plug those into the objective function 1000x plus 750y, each of those 3 points. So you'll get 3 different values. Whichever one is the lowest value or minimum value will be your answer to number 5. The x point that you used to get that will be the answer to number 6, and the y point that you used will be the answer to number 7. Now let's look at our last section. On this section, I took a large problem and broke it down into small steps because we have to find the constraints of what the farmer can grow, and we also have to figure out his objective function so that he can maximize his profit. So let's take a look at number 8. A farmer plants white rice and brown rice on 10 acres of land. What is a constraint inequality, such as x plus y is less than or equal to 10, that can be written for this? Let x represent the white rice and y represent the brown rice, and you may type in less than and then the equal sign in place of less than or equal to. That's because on Google Forms you can't type this symbol in, the less than or equal to symbol. So what you do is you type these 2 symbols in its place. This is what you would do on a spreadsheet program. Now, the total number of acres that he uses is x plus y, and it must be less than or equal to 10. You'll notice that's the same as the example right here. I'll just have to be honest with you. Jehudi hacked into my computer, and he gave you the answers to number 8 and to number 9. So you can thank him for that, but I'm going to have a nice long chat with him about that later on. So yes, that's the answer to number 8, and that's the answer to number 9. So we can move on down to number 10. We take those 2 inequalities that Jehudi gave us, and we also take x is greater than or equal to 0 and y is greater than or equal to 0 because we have to have positive numbers that we're going to farm, and we're going to put those into a Desmos graph, and it looks like this. Now I have to zoom out in order to see the shape, and we're going to move it around just a little bit. All right, this time you can use 0, 0, but you're going to see it won't give us the maximum value anyway. Once you type these in, and to get this less than or equal to, you type in the less than sign, and then directly after it, type in the equal sign, and it will make it look like that. Once you get those 4 graphs in, you look for where all the 4 graphs overlap, and that is this quadrilateral that almost looks like a triangle, except it's this part that's cut off. And you click on the corners of that shape, and Desmos will tell you what those vertices are: 0, 0, 0, 10, 8, 2, and 9, 0. So that's your answer to number 10. You type those in, just as the example shows you. This example is not the correct answer. You type those 4 points in that were in the graphs: 0, 0, 0, 10, 8, 2, and 9, 0. Now, what do you do with those points? Well, first we have to have an objective function. The farmer can earn a profit of $5,000 each for each acre of white rice and $3,000 for each acre of brown rice. An example of what it would look like would be P equals something X and something Y. In other words, something X and something Y. So you can type it in like this. And that will be your answer to number 11. Now you take those 3 points. You can eliminate 0, 0 because that we automatically know that won't give you the maximum value, and plug in those XY points that you answer for number 10 in place of X and Y. Whichever one gives you the maximum value will be your answer to number 12. The answer that you get on the end is your answer to number 12. The X and the Y point that you used will be your answers to number 13 and number 14. As always, please send me an email if you're having any trouble, and I will see you later.